Alright, now that we know how to multiply radicals, we're going to learn how to divide radicals. So just to review the product property of radicals, as long as the index is the same, we can multiply the radicands together. We can also separate factors as long as we keep the index the same. Now the quotient property of radicals says that if you have a quotient in the radicand, you can separate that quotient and take the root of the numerator and then the same root of the denominator. So see how this just became one root, and then that root became the root of the numerator and then the root of the denominator. So, for example, if we have the square root of 40 divided by the square root of 5, remember that square root is really a fraction, so you can rewrite it as the square root of 40 in the numerator and the square root of 5 in the denominator. Then, using the quotient property, you can rewrite that using one root, so now we have the square root of 40 over 5, and then we can actually do 40 divided by 5, which is 8. And the square root of 8 simplifies to 2 square roots of 2. Alright, next example, the square root of 15 over the square root of 12. First, using the quotient property, we will rewrite that as one radical. And then 15 over 12 reduces to 5 over 4. And then, from there, we'll go ahead and use the quotient property again and separate the numerator and the denominator. So we have the square root of 5 over the square root of 4. And the reason that we want to do that is because the square root of 4 is actually 2. So our final answer becomes the square root of 5 over 2. Now, fractions that have radicals in the denominator or radicals with fractions in the radicand are actually not considered simplified. So if we have one, we have to take care of it. And the process of removing the radical from the denominator is called rationalizing the denominator. So this is a term and a verb that we have to get used to because we'll be using it. It's called rationalizing the denominator. So first we have the square root of 5 over the square root of 7. So because we have the square root of 7 in the denominator, that is not okay. We're going to use the product property, and we're going to multiply the numerator and the denominator by the square root of 7, which is essentially multiplying by 1, because the square root of 7 or the square root of 7 is the same as 1. And you can multiply anything by 1 and it still is itself, because anything times 1 is itself. So the reason that we picked to multiply by the square root of 7 is because we know that the square root of 7 times the square root of 7 is 7. So that means that our denominator no longer has a radical in it. And the square root of 5 times the square root of 7 is the square root of 35. Alright, so now we have the square root of 3 over the square root of 6. So first we'll use our quotient property to rewrite that as the square root of 3 over 6, which simplifies the square root of 1/2. Then we will use our quotient property again to take the square root of the numerator and the denominator, which is the square root of 1 over the square root of 2. Now the square root of 2 cannot be in the denominator, so we'll multiply both top and bottom by the square root of 2. 1 times the square root of 2 is the square root of 2, and the square root of 2 times the square root of 2 is just 2, giving us our final simplified answer of the square root of 2 over 2. Our next example, we have the square root of 2 over the square root of 75. So for here, we're going to use our quotient property. Before we use our quotient property, let's notice that the square root of 75 can actually be simplified, right? The square root of 75 is actually 5 square roots of 3, because the square root of 25 is 5 times 5 times 5. 5 times 5 times 3. So 5 square roots of 3 is the same thing as the square root of 75. So now that we have that, now we will rationalize the denominator by multiplying by the square root of 3. So the square root of 2 times the square root of 3 becomes the square root of 6. And then the square root of 3 times the square root of 3 becomes 3. But we already had the 5 there. So then we have to do 5 times 3, which is 15. So our final answer becomes the square root of 6 over 15. So here are steps for rationalizing the denominator. Step 1, we're going to write both radicals in fractional form. And then once we have them in fractional form, we'll simplify both the numerator and the denominator as much as possible. So that just means simplifying your fraction. So for example, 2 over 4 will become 1 over 2. Once you've done that, if you have a radical that is left in the denominator, multiply by the form of 1 that makes the radicand and the denominator a perfect power. And then simplify both the numerator and the denominator and reduce the fraction if you need to. Alright, so let's look at this. We have 3 roots of 8 over 3 roots of 16. So first we will rewrite this as 3 roots of 8 over 16, and then 8 over 16 reduces to 1 over 2. And then we'll rewrite, and so we have 3 roots of 1 over 3 roots of 2. Now, we can't just multiply by the third root of 2 because that would only give us 2 2's. We need 3 2's for them to break out. So we have to multiply by the cube root of 2 squared. So that way we'll have 1, 2, 3 2's, which means that it will simplify and come out of the radical. And then the cube root of 1 is just 1, which is how that became a 1. So we're multiplying by the cube root of 2 squared by top and bottom. 1 times the cube root of 2 squared is the cube root of 4. And then, of course, we multiplied by the cube root of 2 squared, so this 2 could break out of the radical, leaving us a 2 in the denominator, which gives us our simplified form. All right, last example. We have the square root of 18a squared bc squared over the square root of 9ab cubed c cubed. So first thing we want to do is rewrite that as one fraction using our quotient property of radicals. Then we'll simplify. 9 goes into 18 twice. This a will cancel one of those a's, leaving us an a in the numerator. This b will cancel one of these b's down here, leaving us a b squared in the denominator. These 2 c's will cancel 2 of these c's, leaving us a c in the denominator. Now that we have done that, we'll rewrite using the quotient property. So we have the square root of 2a on top, the square root of b squared c on bottom. The square root of b squared, however, the b can come out, leaving us b times the square root of c on bottom. Now we'll rationalize the denominator. So we'll multiply both top and bottom by the square root of c. So we'll get the square root of 2ac on top, and then we'll get bc on bottom.